We're now going to look at using ASA, angle side angle, to prove triangles are congruent. Here it asks us to make a two-column proof to prove that triangle ACB is congruent to triangle ECD. We know that BAC is congruent to DEC. It's given to us both here in the givens and in the diagram with the little pink line here. And they tell us that BD bisects AE, which means that point C is the midpoint of those two lines. And we want to prove that this triangle here is congruent to this triangle here. So the first thing we want to do is we want to write down the given information. So we write down that angle BAC is congruent to angle DEC. Then we write down that BD bisects AE because that is also given to us. And we write down that AC is congruent to EC because that's what a bisector does. The definition of a segment bisector tells us that AC has to be congruent to CE. Next, we look at angle ACB and angle ECD, and we know that they are congruent to each other because they are vertical angles, and the vertical angles theorem tells us that those have to be congruent to each other. Now, based on that information that's given to us, we now have an angle, a side, and an angle that is congruent to the corresponding angle, side, and angle of our other triangle. So therefore, those two triangles are congruent by angle, side, angle. The important thing to remember with angle, side, angle is that the side is included between those two angles.